Alright, so today we're going to go over an 820-3462 board that has no power after a keyboard replacement. And as you can see, to make Eli hush, I have gotten rid of the grape. Let's see if it affects audio quality. Now, first thing to do here is see what it does when you plug in the power adapter. So I'm going to plug in the power adapter, and there's no light. Now, the one-wire circuit is what's responsible for creating a green light in the charger. Now, for those of you who have been watching this video series for a while, you should know that you need pp3v42_G3 hot to be present in order to have a green light in the charger. If you haven't been watching for a while, watch the one-wire series videos. It's about 11, 10-minute video that really sums up how that whole thing works. So let's switch and open Broadcaster, and as you can see, they have these really cool transitions now. See that? Oh, that is amazing. I got spoiled by this. Open Broadcaster is great software. If you like these videos, you should donate to the Open Broadcaster project, because they just keep making it better and adding features when there's really nothing in it for them to be doing so. I gave them $100 a while back. I should probably give them more. It would be impossible to do these videos regularly without something that actually works like that. So, pp3v42_G3 hot is going to be created by U6990. So let's check out where U6990 is at. Oh, I'm hitting next page, not next result. Duh. Alright. Remember, see this is the one-wire circuit. This is what's going to allow the charger, which is plugging into this DC inboard over here, to talk to the SMC. This chip is powered by SMC, BC, ACOK, VCC, which comes from this chip, which is powered by PP3V42. So if I have no green light, first thing to do is check that PP3V42 is working. And it seems like we can check for PP3V42 over here on L6995. That's an inductor that's going to be smoothing out the switching power supply. So this is taking either PP bus G3 hot, which is going to be coming in from the battery, which is 12 volts on this machine. The schematic is stupid and mistaking it for 18.5 volts. Don't get confused by that. This is supposed to be 12. Or the DC inboard, which is 18.5 volts. So let's check L6995 and see what we get. See, can I do some pretty... Oh, you can do some pretty cool transitions here. So I can find it right over here. First thing to do is adjust this so that it's in better focus. Okay. It's in focus for me. Now let's make sure it's in focus for you. All right. So that is L6995. See? L6995 over here. L6995 over here. So the first thing I'm going to do is check and see if there's a short to ground there. So let's just show you on the multimeter how I do that. I got to get used to my shortcuts. So what I'm going to do here is I'm going to take the red probe and put it on ground, and the black probe and put it on where PP3V42 is, and the multimeter reads 0. So if I do this, you might be able to see that it reads 0. That means that there's a 0 voltage drop across these two probes. So the way this works is when I put the multimeter to this ohms symbol over here, I have it set to ohms, which you may not be able to see, and then I click this little yellow button until I get to a diode symbol at the top. That's diode mode. Do this, and I get a 0. So that means that there's 0 voltage drop across the points, obviously, because they're touching. And what I'm doing over here, under the microscope, I'm taking the red probe and putting it on, some kind of screw holder, grommeter, metal piece that is in like casing, like this. And then I'm taking the black probe and I'm putting it over here on the inductor. Now that means that there's a short to ground. Now, the first question that I'm going to have here is, those transitions are beautiful, is what side is the short on? So is the short to ground on my system side, where PP3V42 is going to the rest of the computer, or is it before the inductor? Could it be this chip that's shorting? Could it be one of something over here that's shorting? So the first thing I'm going to do to try to isolate where the short actually is in this scenario is I'm going to remove the inductor using my hot air station. So that means turning on the air filter because I don't like breathing in crap. So we do that. Let's remove the inductor. So the air on here is set a little high. I'm going to set it to 54. And I'm going to set the temperature to 400 Celsius. Bonus points if I don't burn that keyboard backlight connector. I think that's what that's for. So the inductor is now removed. So what I'm going to do is I'm going to see which side my short is on. So let's go back here. Let me just rotate this so that it matches. Ow, that's loud. Let's rotate it so it matches what is on the way the board is. I've lost the board now. Great. That means I have to reopen this. This software sucks so bad. Here we go. Where was my inductor? My inductor was right over here. So the system side is the top, and the chip side is the bottom. So this over here, number one, that's this over here. And the top is where PP3V42 is going to go to the system. So now we're going to check which side my short is on. So again, black is going to go here. So let's see, is it the system side has a short, and the side that's creating PP3V42 does not have a short. So what this means is that there is a short circuit somewhere over here, anywhere in the computer actually, anywhere where PP3V42 is present. So what I can do is something like this. So I know that my short is going to be somewhere where PP3V42 underscore G3 hot is present. So it can be any one of the components that, or probe points that just popped up. It can be that pin, it can be something over here, something over there, something over there. Hope to God not any one of the many points over here. On the other side of the board, it could be many different things. So the way I'm going to figure out where my short is through a little bit of fun. So what I'm going to do is set my power supply here up so that I can find the short. So what I do on this power supply is I'm going to set the current to the maximum current that it's able to provide, which is 10.238 amps, which is really not needed. And I'm going to set the voltage to 0.5 volts. Now I'm going to take the power supply wire and I'm going to solder the ground of it to ground and the positive of the power supply to the PP3V42 terminal, and I'm going to send 3.42 volts to the machine on the 3.42 volt line. Now, since the computer is actually, this is the motherboard itself, so there's some component on here that is completing the circuit to ground. When I do that, whatever component it is going to get nice and hot, and it will give away the fact that it's bad. That's the idea here. Let's see if that's how it works out. I really shouldn't be using a micro pencil for this. I just don't feel like switching the irons. And now for the fun part. We turn it on, and it's drawing 0.1 amps at 0.5 volts, which is, I am never going to feel what's getting hot. So I'm going to turn it up, 2 volts at 0.6 amps. That's about a watt by Ohm's law. That's still, I'm not going to feel that at all. So since it's not really drawing a lot, I don't feel bad turning it all the way up to 3.42 volts. 3.423 volts at 0.9 amps. That's almost 3 watts. At this point, I stand a fighting chance at actually finding what it is that is shorted. So we're going to feel around the board here. Move microscope out of the way for a second. And put the multimeter where it's comfortable for me. I was putting it there so you could see it in the video, but it's really a pain in the ass for me to have it over there. Put it right over here where I like it. Now, I've learned my lesson on feeling the board with the side of my face. The side of your face is a sensitive piece of skin, but the same, I may want the side of my face someday, that may come in useful. Might go on a date or something, you never know. So I'm going to put a little paper towel on my desk. And I'm going to pour some cheap-ass alcohol on the board, and we'll see if anything sizzles. And if something sizzles, then I have an answer. Now the other thing I do is I keep my board view open using the Nets feature, where I can see every point that PP3V42 shows up. So that I kind of know where to look for the alcohol to be sparking or doing something funny. Gives me a little bit of context. Now what I notice on this side of the board is that there's pretty much nothing that's drawing anything. So I'm going to turn it around. Now we check the other side and we see where we go from there. And it appears that nothing is getting warm. Not even close. That kind of sucks. Yeah, nothing is making the alcohol bubble. I hate looking like an idiot on camera. But it is what it is. So there is clearly a short to ground. There is 0 voltage drop here. And this is set to not limit current. And we are delivering about 3 watts. So, I mean, 3 watts is something. You should be able to feel 3 watts on this board. I would never deliver 3 watts to an iPhone, but this is a larger board, so I feel safe with it. 3 watts should be something where it's like, oh, it's obviously this, because I can feel it burning my finger. This is one of those things where that FLIR cam might actually be useful, but I don't feel like spending money on it. It'll get solved. Like one way or the other, it will get solved. It's just a question of whether it's a pain in the ass or not. So this is where we go under the microscope and we start investigating. Alright, so let's investigate under the microscope. See if anything looks like it's burned away the alcohol. And I'm going to pour it into a little cup and just pour a little bit more alcohol. You may think this is a waste of alcohol, but wait till you see how much freeze spray costs. $20 a can. Fuck that. Okay, so we have nothing over there. Remember, there is no PP3V42 components over there. So over here, there's some PP3V42, and yeah, again, 3 watts, you would see that burning away quickly. The keyboard connector, not even close. Alright, so I'm looking at my board view, see where else there's some PP3V42. So next to this fucked up looking battery connector, there's some PP3V42 over there, nothing. Okay, and then we have this upper right corner over here, where there is a load of PP3V42. We put some alcohol over there, and yeah, 3 watts would burn that away really fast, and there's no burning away that I can see. Okay, so we hit spacebar, got spacebar. Now we move over to the other side of the board, and let's take a look, see if anything's getting delivered there. So we have some PP3V42 above over here. Yeah, and the alcohol is not even close to burned away. Some over here on this little piece, but nothing. No dice. Some on the bottom of the board over here, and what are you? What are you, you little burn mofo? I know what you are. You're a resistor that leads up to the PP3V42 power supply. But you don't have a path to ground. So WTF. You look dirty, sure, but I don't really care about you. You wouldn't cause a short to ground. So why am I saying that would not cause a short to ground? So what that over there is this thing over here. See this? This is a resistor in between the DC in board and the diode that leads up to the PP3V42 power creation chip. So that can't possibly be what's shorting anything to ground. I mean, it doesn't have a path to ground. That would be silly. So we continue moving around the board, and okay, so this is giving me a little bit of a hint right here. This is a greater hint. So this chip doesn't. This is where it gets tricky. So in this specific schematic, there is PP3V42. Actually, wait, yeah, there is PP3V42. I'm looking at the wrong section. Yeah, PP3V42 does actually go into this chip, and what is that little mark on top of it? What's that? What's that? Is that a freckle? Could that be a freckle or a beauty mark, or is that a sign that that is fucked? And let's see on the board view over here. So if I just hit control, here we go. So yeah, I mean what I'm looking at right over here is this. So there's a pin on this chip that gets PP3V42, and if you look over here, my little mark on that chip, wow, this was a bitch, is right in the area where that pin is. So this is where the pin is over here. See that? The third one on the upper left. And then right over here, you got the little burn mark. So here's what I'm going to do. I'm going to keep the power going into the board right now, right? I'm going to keep the power going to the board. But what I'm going to do is I'm going to remove that chip, and I want to see if the power supply stops delivering power to the board. I'm not going to keep 3.4 volts going through it. Let's see if it actually is a little bit warm. I'm going to lower it to something like, half a volt, right? So I'm going to lower that to just half a volt. There's no reason to keep voltage going through now that I believe I found the short. And I'm going to look at this thing, and once I remove that chip, if I see that the power supply is no longer delivering power, I know that I caught my short. I just wait for my hot air station to get hot, which I almost forgot I don't have to do anymore because this is a JBC JTA, and this hot air station gets hot literally instantly. I mean, there's no wait time on this. I do this. I mean, I'm trying not to touch the actual metal ends of the chip. And now, okay, I removed it, and my short's gone because it was delivering 0.1 amps at 0.5 volts before, and now it's delivering 0 amps at 0.5 volts. I'm going to turn the power supply off. I know that I found the cause of my problem. And let's just go over this a little bit. We're going to get rid of all that lead-free solder on every side. So the whole idea here is the lead-free solder is going to get sucked up onto that leaded solder ball that I'm running along there. Suck up all the nasty lead-free solder on every side. It may seem like I'm using quote-unquote too much solder. The thing is, I don't actually keep that on the board. That goes away. I'm using that so that I can remove the old solder on those pads without having to resort to wick and changing tips and wasting time. Okay. See how much nicer that looks? Sad thing is you're never going to see how nice this actually looks when I'm looking at it, because even though I got this new 422 lossless capturing setup, before it was screwing up when you would try to... So screwing up the color space, and also it was stuck at 420. But even though you see that, YouTube only allows me to go up to 420, so you'll never see how good it looks when I'm actually looking at it. But I think this looks pretty damn good right now. Pretty nice capture setup. So now I just got to grab myself a chip. I actually forgot the orientation. Great job, dumbass. Great job. And I would actually have to stop the recording so that I can view what the orientation is. Aw, that's just dumb. Alright, so I found the way it's supposed to go. Great job, idiot, for not remembering which way it's supposed to go. So let's put that chip on there and finish this board up. So let me just get the JBC started. It's nice and noisy. And as always, I put too much solder on the center pad. That seems to be a cardinal hallmark idiot thing that I'd always do. But you'll see that it's not really going to matter much. Let's just move this back into proper view. Again, I don't expect that to sit perfectly when I just put it on there like that. And of course it's going to blow away if you try to get it to sit perfectly. Especially when there's such a mountain on top of it. So I'm just preheating the board at the moment. Then So yeah, that's once it's aligned, once it's aligned, it really will just pull itself into place. So you don't have to align it perfectly. You just tap it a few times, and you'll see when you're good. Now, of course, there's all this excess, and the thing is, people try to get it so that that doesn't happen while they're aligning it, because I think that people don't understand that you really can adjust it later. It really doesn't matter. Like, you put some flux, you have a nice blade tip like the T30-KN. That's T30-KN tip for the Hakko 2032 iron. So that's the T30-KN tip for the Hakko FM-2032 iron, like what I have over here, and you just go around it like that. And you're good. Now what I do after I'm done with all that, just to make sure that I've got it nice and flat on the board, I may heat it another time, and push down. So I had it aligned at the beginning, but obviously since there was too much solder on the center pad, it may be sticking up a little, so I'll just do this and wait. Hot air is almost fully heated up. Just go around it a little bit. Wait for it to melt. Push down. Yeah, it's important that this be flat on the board. I'm pretty much done. Yeah. I'm not the smartest guy in the world, not the best at soldering, but it's the thing. You don't really have to be. This is dumbass consumer laptop repair. Any idiot should be able to do this shit. So, what was I doing over there? Why was I cleaning what was already fine? That was dumb. More dumbness. I can live with that. Alright. Now we have to put back on the inductor. Which I haven't knocked off the table. That's surprising. Quite surprising. This is going to be a pain in the ass. This tip is totally not meant for what I'm doing with it. Come on. You can do it. Yeah, you need to use the not micro tip for this. This is dumb. I should just stop being stubborn and just change the fucking tip. There we go. Joy. I have to remove that solder anyway with the larger tip, so I don't know why I'm fighting. So hard to not use it. Get that in focus. Alrighty. Now let's put the inductor back on. That does not have it. This specific component does not have an orientation. An inductor is a coil. A coil is really a wire that is just kind of. Oh, I forget what I was just talking about. I'm sure I'll remember later when I'm done with the video. I was in the middle of something. I just don't remember what it was. Alright, so again, bonus points for me if I manage to get that thing on without burning the keyboard backlight connector. Another thing to understand here is to always put the have the board oriented where it's comfortable for you. It shouldn't matter to have the board oriented like, where you think it should be. It should be where it's comfortable for you. So again, if I'm going to be blowing air, and I don't want the air to get here, I'm not going to blow from here, because then I'm going to get it on there. I'm going to blow like this, which means turning the board around. So feel free to turn the board around as much as you need to make it comfortable for you to make the measurements that you need to measure or do the soldering that you need to do. And preheat it. Preheat the whole section. So that when I decide to actually go in really close, when I'm going to be close to the connector, I don't have to spend as much time there. And boom. I push down. The reason I push down is because, as I said, it is important to have all these things flat on the board. Harder to knock them off, harder to damage. Okay, now the million-dollar question is, do we get a green light on the charger? Damn, this place is noisy. Ugh. So much noise everywhere. We have a green light on the charger. Now an orange light in the charger. And that's that. No, really, that's that. I'm sure that everything on this board works perfectly fine. What, you want me to test the rest of it? What is this, a paid YouTube channel?